Okay, so I'm going to make this video to try to help you with problem set number 1. And the first thing I got to say about problem set number 1 is the point of this problem set is to take a bunch of formulas which you are not familiar with yet. So we really don't care what the formula stands for, and to rearrange it in a way that you might be able to use it in some experiment. It's not important right now what the experiment is. What is important in this problem set at the very beginning is to learn the process of undoing algebra. I think that's the easiest way to put it. So let's take this first one as an example. So you're trying to get a formula that would solve for f. And by the way, that's frequency, but you don't need to know that now. And you have a formula that says v, velocity, equals the frequency times lambda, the wavelength. These can just be gobbledygook. But you're looking here at f, and you need to get a formula that has f on one side. So you really want something that says f equals. And the question is, how do you get to that? So we need to unwind the algebra here. F next to lambda means times. When they're next to one another, that means multiply. And so to undo that, to get velocity by itself, we have to do the opposite of multiplying to get lambda on the other side. So what's the opposite of multiplying? Well, that's dividing. And I'm going to divide this side by lambda because those will cancel. And then just like in math class, I have to do the same thing on the other side, right? What you do on one side of the equation, you have to do on the other. That's what that equal sign means. So if I do that, then I get a formula for f, or frequency, that equals velocity divided by lambda. Or frequency, f equals v divided by this funny symbol. We don't care what that symbol means. So that's the first thing about rearranging a formula. And again, this is just a math skill. We're not concerned with what these formulas do or stand for. All right, so let's try to do the next one. So now we're solving for I. We have no idea what I is. And again, we've got I squared times R equals P. So our first step is to get I squared by itself. And that means we can do the opposite of multiplying, which is dividing by R. Okay. Those cancel, and you get I squared equals P divided by R. And we're not quite done because we need a formula just for I, and so we have to undo this square. And the way you undo a square is by taking the square root. So if I take the square root of both sides, remember it says equal, so whatever I do to one side, I have to do to the other, then I'll get the formula. Well, the square root of a square is just the variable itself. So that's just I, and there's no squares here, so I can't undo that. So I equals the square root of P over R. And there's my formula. And so if someone was to give me the value of P or the value of R, I could put them in here, divide them, take the square root of it, and I would know what I is. We don't know what I stands for, but this is just how I can rearrange a formula to be able to use it for this. All right. So here we're trying to solve for t, and this is a two-step thing now. T is in the denominator. We need to get it in the numerator. And one way to do it is to multiply by time. So I have v av, which stands for velocity average, equals delta x. Remember, delta means change, divided by time. If I multiply this side by time, and obviously I have to do it to the other side too, these cancel, and I get t times v average equals delta x. And remember, I'm trying to make an equation for t. So I'm not done yet, because I don't have an equation that says t equals. So what do I need to do next? Well, this means multiply. The opposite of multiplying is dividing. So I can divide by v average on both sides. V average. These will cancel. And now I get a new equation that says time equals the change in x over v average. And again, we don't need to know what t or x or v average stands for. We are just trying to algebraically rearrange the equation. All right, I'm getting a little more complicated here. So now we need an equation for t if v naught equals 0. Well, the nice thing about this is if v naught equals 0, if I'm going to put a 0 in here, 0 times t is 0. So I get to get rid of that part of the equation simply by plugging in v naught here. Because remember, if that part of the equation said v naught times time, and v naught is 0, that's 0 times time, and that's just equal to 0. So we can ignore that part of the equation. So now we have an equation of delta x equals 1/2 at squared. All right, so I need to get a formula for t, and this mess over here just means times. It means 1/2 times a times t squared. And I need to get t by itself, right? Because I'm solving for t. So what I'm going to do is I'm going to divide this side by 1/2 a, because those will go away, and this side by 1/2 a. These cancel, and now I get t squared equals delta x. All right, so I could divide by 1/2, but in math class we've learned that that means multiply by the reciprocal. So that would be 2 over a, 2 divided by a. My mistake, sorry, because it's the reciprocal of 2, but a still stands below. And we're not quite done, just like before. Just like up here, we have to take the square root of both sides, and so we get t equals the square root of delta x times 2 divided by a, all under the radical. All right, so we'll probably do this one in class together and this one together, okay? Well, we'll talk about that in class. Let's do this one. So this is t, it's a type of time, equals 2 pi times the square root of g divided by L, and I need to solve for L. So how am I going to start this? Well, I need to unwind the algebra again. This means multiply, right? These two mean multiply. So the first thing I'm going to do is divide both sides by 2 pi. So t divided by 2 pi equals 2 pi times the square root of g divided by L divided by 2 pi. 2 pi cancels. All right. So now I get t divided by 2 pi equals the square root of g divided by L. What am I going to do about this? Remember, I have to get to L. So you've got to unwind the square root. Well, how could I unwind the square root? Well, I could square both sides of the equation. If I square this side of the equation and that side of the equation, remember, whatever you do on one side, you've got to do on the other, then this square root goes away. And by the way, I have to square these guys down below. That's the mistake a lot of people make. So if I do that, I get t squared divided by 4 pi squared, because even pi has to be squared, equals g divided by L, because I've got, by squaring the square root of it, I've gotten rid of it. And you're like, I'm done. So what do I do next? Well, the next thing I can do is that I can multiply both sides by L. All right. And I get L times t squared divided by 4 pi squared equals g. And I can divide both sides by t squared divided by 4 pi squared. This is t squared divided by 4 pi squared. This cancels. And what do I do about this mess? Well, again, in math class, it's the reciprocal. So if you've got g divided by t squared divided by 4 pi, it's the same as multiplying by the inverse, and so that's equal to g times 4 pi squared divided by t squared. This is one of the hardest ones that we'll do the whole year, okay? Try to remember in this part, this is just algebra. There are hints for all of my problem sets, and I hope that helps you.